Got it up. Where is it? It's not loading. Okay, here we go. Look at this. Right there. 5.02K? Are you kidding me? 5,000 subscribers. I hit 5,000 subscribers yesterday. And ever since yesterday, I've been excited about just getting back and recording again. I took a 3-week break where I was just kind of relaxing, and due to the whole coronavirus thing, I don't know. It's just sometimes you just feel like shit. At the end of the day, I'm working 9 to 5, and at the end of that, I just don't want to continue working. So I took a 3-week break, but hopefully I'm back now, especially after hitting 5,000 subscribers. Thank you guys so much. I truly can't thank you enough. Quick announcement, I want to make a thank you to Kuba Jaro, who is our first Patreon subscriber or patron. This is him right here, this lovely guy. Went ahead and, even though Patreon is not really set up, already started donating, and I can't thank you enough. I'm really excited about that. But anyway, that's enough for the announcements. Today we're gonna work on using Three.js and React.js so that we could actually use some 3D modeling, or kind of create a 3D model in React. Now, using Three.js and React is a bit tricky, but we have Paul Hirschman, I believe his name is, who created React 3 Fiber, which allows us to start using Three.js inside React.js really simply, and that's what we're going to do today. The video you see on the screen right now is what we're actually going to be making, which is a simple sort of 3 boxes, and they kind of have this little wobble effect to it, and we can kind of rotate around. So it isn't all that impressive, I know, but we've got to start somewhere, and we're starting at a very basic level. Now, we are going to get much more advanced. This is just the first episode of using the React 3 Fiber. If you have any comments, questions, or anything like that, go ahead and leave it down below, and I'll try to answer them best as possible. Thank you for 5,000 subscribers. We're really looking forward to growing the channel even more. Have a wonderful day, guys. Please stay safe out there. This coronavirus is not a joke, so please be careful out there. Have a wonderful day, guys. Enjoy the video. Alright, so to get things started, you have 2 options. You can skip over to this exact time frame, and that is where we'll start from scratch using Create React App and React 3 Fiber, or you can kind of sit through the first few minutes just so that we can talk about the final project. If you want to download the final project, you can head over to my GitHub repo and clone the final files. From there, you can run npm run star, and it will give you this project here. Now, the idea behind this is we're going to keep it very simple. We are going to create 3 different blocks or mesh, and then we're also going to give them a little wobble effect as well as rotate them. And then we're also going to use different lighting sources to create some shadows, as well as give these shapes a bit of reflection. We can also zoom in and out, as well as rotate the canvas around. If we click on these individual items, they will expand like so. And if we click back on them, they will shrink. So honestly, it's just a really simple project, just so we can have a good understanding of how React 3 Fiber works. Let's go ahead and jump into the code and look at our project files. There isn't much to cover here, but I've added a lot of comments just so that we can kind of have a better understanding. So I do have a header.js file, which is just the header, this React 3 Fiber episode 1, and you don't really need to worry about that. So we can close out of that. We can also close out of package.json, and for app.css, there really isn't anything here new. This is mainly just styles for the header and the body, so we can get rid of that as well. Everything we need to know is really coming from app.js. So at the very top, we're importing useRef and useState. Under that, we're importing canvas and useFrame from React 3 Fiber. And what canvas is going to allow us to do is it's going to set up the scene, the camera for us, and it's really going to make it easy. In Three.js, you'll need to set up a scene, a camera, and different things just to get started. So canvas covers that for us. The use frame allows us to re-render or update the rotation of our boxes at each frame. So once it changes, it will update every single frame. And that serves not just for rotation, but any animation or effect you add to our objects. Like I mentioned before, we are also using dry, and dry is just a quick way to add different effects rather quickly rather than needing to write them using Three.js. What we're importing is soft shadows, mesh wobble material, and orbital control, orbit controls. Orbit controls allows us to move the screen or the canvas around like so, and that gives it a little camera effect. The soft shadows allows us to kind of have, like it says, sort of softer shadows, which I like in my opinion. And then the mesh wobble material is allowing us to have this sort of wobbly effect on all of our shapes, which is really popular, but Not a lot of people use it like this. A lot of people use it on sort of images, but as we get more advanced, we'll cover that. We're importing the header component and the styles, which is pretty simple. Then the React Spring for our scale animation, we're using use Spring and animated. This A represents animated. If you're familiar with Framer motion, it's sort of similar to this. So when we select on our mesh, they do scale up and down. We're calling soft shadows here. We're executing the function at the very top. That's all you need to do for soft shadows to enable it. And then we have this component which is called spinning mesh, and spinning mesh represents each individual block. We're importing or using destructuring to import different props, and these props are executed down below. So we call this spinning mesh 3 times, and then we pass certain props just so that we can have different effects for each individual block. If we scroll to the top, you can see that we're using a ref to just get the reference of the mesh, which we have here. And then for our use frame, we're executing the following to get the rotation to happen. So as each block is just spinning in its own sort of axis or its own sort of block, that's how that is working with the use frame. We have basic state, expand and set expand to expand our blocks, which we covered already. And then this can go away. I was just testing something. Then down below here is where we're building out our box. So we're using a mesh. We can get rid of this console log as well. We're using a mesh, and then inside of the mesh, we define what kind of shape and the material we want. So box buffer geometry represents a box, and then this mesh wobble material represents this wobbly look, as well as the fact that we can add different colors on there. So typically you'll always pass a buffer geometry and a material into your mesh so that you can define the shape and the effect or color on that specific item. So as we build out, I will use different shapes, but we'll ultimately reflect back to the box buffer geometry, and it will make more sense as we're building. Down below, I do have this commented out, which we can use dry to go ahead and create a box, and we can pass in a mesh wobble material. So we don't need to pass box buffer geometry. This right here is just using Three.js to build our cubes. If we wanted a quicker way to write a cube, we can use box from dry. Again, dry is just that quick snippet code that we could use, and it has different items that we can import. So you could use this version to create the same effect. This is just Three.js, and this is just using dry. Down below, we have our app function, which is just rendering our app. Now, to write Three.js code, you need to write it inside of a canvas. This canvas is imported from the React 3 fiber. It isn't your typical HTML canvas. Inside this canvas, you can then write any and every Three.js property you want. And what we have here is different light sources that we're using from Three.js. Ambient Light, I added some comments, so I'll just read those. It sort of makes things look a little pretty. From my opinion, I'm trying to dumb it down in terms of definitions. Directional Light, this is going to be our main source, which sits at the top. You won't be able to see it, but it will sit up here, and it shines down. So directional light is always sort of your main source of light. You could point it in any direction. It also casts shadows, so that's really important. Then we have 2 point lights, which the 2 point lights kind of sit right here and right here. And so you can see that it's hitting on the left side and the right side. And point lights do not provide any shadows, and they're kind of just sources of light. If we get rid of this, actually, you'll see, and save it. So you can see it's a bit dark on the right and the left sides of each section. So if we add point light, it kind of just illuminates the different objects that we created. Then we have a group, and this group represents the different items that we have displayed. So we've got 3 spinning meshes, and then we've got 1 custom mesh that we created. And the 3 spinning meshes, these are custom components that we created at the very top. And then we're passing props, which we've discussed. But then this mesh over here, this is going to be our floor, which you can't see it, but in order for the shadow to be casted, we need to have a floor or a plane kind of set at the bottom. So if I were to go ahead and get rid of this or comment it out, you could see that the shadow is never defined, or you can't see the shadows at all. That's because no floor is defined. If we get rid of the first spinning mesh, it's going to get rid of the big blue one. And honestly, that's really it. Oh, I'm sorry, I forgot one thing. The orbit controls, which allows us to move around the canvas in different perspectives like so. So all we do is import it from dry and then add it here as a component. So it's really, really easy. Honestly, using React 3 Fiber is much easier than Three.js in my opinion. There's a lot of boilerplate when using Three.js, and React 3 Fiber handles a lot of that for us. So if you're excited about this, let's go ahead and jump over to the next screen where we're going to use Create React App and install all the following dependencies to get started. Okay, so I'm already in Hyper.js, and Hyper.js is just my terminal. All it is just a pretty version of your typical command line interface. So from here, we'll go ahead and do npx create-react app. And we can name the app anything. We're gonna call it React 3 cubes, I guess. This will go ahead and get Create React App installed for you. And after that, we're gonna move on to install the required dependencies that we need. Once that's done, let's go ahead and cd into our project. So we could do React 3 cube, and there's no directory. It's React 3 cubes with an S. And from here, we'll install all of the dependencies. So we're gonna install Three.js, and we're using Yarn. You could use npm if you want, but for Yarn, you'll do yarn add, and then the dependencies you wanna add. So we're installing 3, we're installing React 3 Fiber, which is the React version of Three.js, or the reconciler. From here, you can go ahead and install Dry. I think it's called Dry. I thought it was Dre initially, but it just means 3 in German. Finally, we're installing Sass and React Spring. And we all know what Sass is for our CSS, and React Spring allows us to do animations similar to Framer Motion. It's just Framer Motion doesn't allow for you to add animations for different mesh or groups related to Three.js. So that's why we're using React Spring, because they're created by the same person. So let's go ahead and clear that and then open this in VS Code. Once we're in VS Code, we can open up the source file. And let's jump into app.js and get rid of everything that's in here. We don't need any of that stuff. We could change app CSS to app SCSS, as well as the file for app CSS. Change that to app SCSS. Get rid of the logo SVG. For the app Sass, we can get rid of everything that's in here and save this. Let's go ahead and open up our terminal within VS Code and run yarn start. And this will open up localhost 3000. Currently it's empty because we deleted everything, but if we write hello, it will show hello on the top left. Perfect. So what I'm going to do first is create some default styles in app Sass, just so that we can have a background as well as basic styles for our HTML and body. So I'm going to add an asterisk, and we're going to give the asterisk box sizing a border box. This shouldn't affect us at all since we're using Three.js, but just always add it in no matter what. Then we have the HTML and the body. We can go ahead and add a width of 100%, a height of 100%. Our margin and padding will be set to 0. And I misspelled width up here, so just make sure you spell it correctly. And then for our body, let's go ahead and add the following. We're going to give it a background color of F1, F4, F8. And we could just make this position fixed. And if you wanted to add text and everything, you can add a font family, but that doesn't really matter. Let's just leave it like this for now, and if we need to make any edits, we can come back to it. Let's go ahead and go into our app.js, and let's put hello back and make sure everything is working like it is. Perfect. Now, the first thing I would like to do is just create a normal box that doesn't have any special effects, just so that we can get some understanding of how this works. The first thing we'll need to do is we'll need to import canvas from React 3 Fiber. So we'll go ahead and import canvas like so. And then I'll go ahead and get rid of this div. I'll go ahead and leave it as a React fragment. And then inside this fragment, we can use our canvas. Now, one thing we need to mention is that we cannot write any HTML within this canvas. Only HTML that is valid is outside of the canvas, and that's because the canvas is only taking Three.js elements. We can go ahead and create a cube by writing the following. First, we'll define a mesh, and then inside a mesh, we'll need to define a material and a geometry for it. Typically, the geometry would define the specific shape, and the material would define the color or the look of the specific shape. What we're going to do is create a cube or a box. So this will require us to use a box buffer geometry. Again, all of this information can be found within the Three.js documentation. Three.js documentation is really well put together. The only issue I have with React 3 Fiber is the documentation is really lacking. So maybe sometime in the future they could really build a good documentation people can follow. So we've defined our mesh here. What we'll do next is define what shape we want, and like I mentioned, we're going to use a box buffer geometry. So let's go ahead and write that. And box buffer geometry can be self-closing. Now when you define these specific elements, a required attribute is one called attach, and this will let us know that if this specific element is representative of the geometry, and when it comes to material, if it's representative of a material specific to the parent mesh or this mesh here. So since this is going to be representative of geometry, so let's go ahead and write that. And then another required attribute is args. And now what this args attribute represents is sort of three things, just the general size of it, right? It's going to represent the height, the width, and the depth. So for now, I'll set everything to 1, but the way to write it is through an array. We'll go ahead and set the width to 1, the height to 1, and then the depth is going to be set to 1 as well. It would also be thought of as, when it comes to working with position, as X, Y, and Z. But this one is specific to args, which is our overall size of the specific item that we're working with. Next, we're going to work with a material. Now, in the final version, we have a mesh wobble material, which makes it wobbly, but we'll get to that in a second. Right now, what we're going to do is just provided a mesh standard material. So to do that, we could just say mesh standard material like so. And similar to the box buffer geometry, we'll need to attach what this is going to represent. It's going to represent our material. Now, before we save, I did make a mistake. I spelled geometry incorrectly. Get rid of that extra E. And let's take a look. What should happen is that we should have a small box or a small cube on the screen. And we do it at the top. Now I want to center this to the center of the screen. And I think the main reason that's not happening is because we need to also add a ID of root to our HTML and body styles here. Let's save that, and then now we can see that it is in fact in the middle of the screen and it's taking up the entire page. So our canvas is in fact 100% of the screen. One thing I forgot to mention in the beginning is the fact that using Three.js without React, you'll have to define the resize handler, you'll have to define where your camera is going to be, as well as the scene, but then Canvas takes care of all of that, including the resize behavior, which is really, really neat. So now that we created a basic cube, I also want to show you if we were to use dry. Dry allows us to pretty much write code a lot faster. And what I mean by that is we can just import a box that's already built by the people at Dry. And what we could do is just render that out here. So we'll render out a box. And if we comment out the mesh that we had above and take a look, you could see that it is in fact a white box. But if we wanted to add a material such as changing the color on this, what we could do is inside of this box, go ahead and add a mesh standard material, which turns it black. Now we can play with the colors. The only thing we need to do is add some sort of lighting, because if there is no light, then there is no color. That's how the world works, I think, at least. Anyway, so yeah, you can reference Dry here, and you can go to their documentation. They have all the shapes you need so that you don't need to write additional code. We won't use box. We're going to just stick with the mesh we created because we want to just understand basic fundamentals here with Three.js. Now we aren't limited to just a box or a square. What we could do is create circles as well, really any shape we want. To create a circle really quickly, we could change this to a circle buffer geometry. However, the arguments that it's going to take for this args is going to be a bit different. The circle will take 2 arguments, and these 2 arguments represent the size as well as the amount of angles that it has. So what we can do here is we can make this the size of a 2 or a scale of 2, and then for the angles, actually, let's not do anything. Let's just leave it as 1 to 1 for now, and you'll see what I mean. So you can see that it looks like a triangle and doesn't even look like a circle. If we update the first number, it's going to get larger. However, the second one represents the amount of angles. If we update this to 50 and save that, you can see that now it looks like a circle, but it's still a bit, it has those angles on the side. The more we increase this, the smoother it's going to look. So if we put this to 30, you can see that it's a bit more rigid, but it kind of has that attribute of a circle. So this is just basic shapes, and you can go through the documentation and get the entire kind of context of how to create different shapes based on your mesh. Okay, so to move on here, what we're going to do is figure out how we can rotate this box, and then we're going to add some lighting just so that we can start playing with color. Part of React 3 Fiber, there is a hook called useFrame, which allows us to re-render based on different movement. So we're also going to need to require us to use useRef. So we'll import useRef because we need to be able to get the reference of this mesh here. I'll go ahead and do the following. I'll create a new useRef, and I'll just call this one a mesh. So I'll say useRef. This one's going to be set to null initially, and then we'll assign this ref as mesh. And then from here, we'll run the useFrame hook. And what we're doing is grabbing that mesh. So we'll use mesh.current, and then we want to adjust the rotation of it. So we're adjusting the rotation of X, which is set to the rotation of Y. So we'll do mesh current dot rotation dot Y. And then for each re-render or each frame, we're adding a 0.01. Now with using useFrame, one hiccup that I've had in the past, and it's mentioned in the documentation, is in fact you cannot use useFrame within your app component or the component being displayed. You'll need to extract this mesh into its own component using useFrame and then importing it into your app or whichever component you're exporting out into the page. So if that gibberish didn't make sense to you, what I mean by this is we'll need to extract mesh into its own component. So I'll go ahead and do box. And what we're just doing here is creating a box into its own component, and then we'll return the following. So again, nothing is being displayed and we have error logs. This is because of this reason. We'll take everything that's we've defined here in mesh and put it into box, as well as the useRef and the useFrame, and put it into box here. What we'll do is render out box in our app component. So I did get an error, and that's because box is already defined with Dre. So we can get rid of that if we want to name this box. We can even name it spinning box because that's what's going to do. It's going to rotate. And if we save this and preview, it's going to start spinning and it works. Now, the reason it didn't work the first time is this useRef is making continuous callbacks for each time this item is being rotated. And so if we have it in our app, it's going to continue to make an infinite loop of callbacks versus having the component on its own and executing the useFrame and then importing it here. This prevents that from happening. And it's also mentioned in the documentation. I just wanted to show the error initially and then have us fix it. So always when using useFrame, it needs to be in its own component like so. Now I want to work a little bit with lighting so that we can start to introduce some color. What I'm first going to do is just add an ambient light. Now to add that ambient light, we're going to add it in our app component, and we could just add it above the box component that we created. So we can just say ambient light. And I wonder if it gives us descriptions here. It doesn't, which is fine. So adding ambient light, we also can add intensity to it. And intensity just represents how intense you want that to be. So I'll just add a 0.3. Let's save this and preview. So now you can see that it kind of transitioned from that dark black color to sort of a lighter grayish tone. And as we increase the intensity, let's set it to 1. You can see that it's going to turn white. If we change this to 0.7, depending on the intensity of the light, that is going then to change the color of the object. We're going to set the intensity to 0.3. And what this ambient light's doing is it's globally illuminating all of the objects on the scene equally. And that makes everything kind of have a bit of light to it, each and every individual object. One thing you need to know is that it does not cast shadows, meaning no matter how intense the light is, there is never going to be any shadows. If we wanted to define shadows, what we could do, having now some sort of light source, specifically with ambient light, we can then start to play around with color. If I wanted to turn this, the cube that we made, to a color of blue, again, make sure that we add this color attribute to the standard material. We can then add color blue and it will turn this cube to a colored blue. We can also add a light blue and it would also turn it to light blue, which doesn't really look like light blue right there, but I guess it is what it is. Green, pink. Yeah, so you get the idea. It isn't all that pretty, but it's going to get there in terms of having that light blue and pink colors we have in our final project. So back in our project here, we'll leave this as pink for now. And two attributes I want to pass into my canvas are a color management attribute. So looking at the colors now, we see that we have pink and it doesn't really look like pink. Once you pass color management, however, you can see that it looks a lot more like a pinkish color, as well as that light blue that we were working with earlier. Having color management now, it does make it look like light blue. I also want to change the angle of our camera. And like I mentioned before, camera is already kind of being defined within our canvas, as well as the scene and the resize behavior. But if you wanted to edit the camera, you can use Dry to add additional cameras, or you can build your own camera as well. But a quick way to do it to change the camera position is adding a camera attribute and then just switching the position. So the position I want to set this to is the following. I'll go ahead and set this to a -5, a 2, and a 10. And then we also have a field of view, and all you PC players, you know what field of view is. It's pretty much how zoomed in or zoomed out we are. So if I set that to 60, you can see that we've changed sort of the camera angle, although you won't really notice it all that much because we don't have any plane to work off of. But we've changed the camera angle in the field of view as well. Now if I change the field of view to 20, you can see that we're much more zoomed in to the cube that we had created already. But let's go ahead and set that to 60. Now what I want to do next is go ahead and add 3 additional boxes and then just change the sort of shapes for them. Now this is the cool part of React, where React allows us to create reusable components and then pass different props so that we can edit them slightly. For the box, I am going to change the name of this and we'll just call this spinning mesh. And we'll go ahead and save spinning mesh, and then we'll render spinning mesh 3 different times. And if we take a look, you won't see 3 different ones. That's because they're all overlapping each other. If we start using positions, we can change the way they're located, and it's sort of similar to this arguments, where arguments is taking a width, a height, and a depth. Position will take X, Y, and Z. But we still face the same issue. So for example, in our position here, or inside the mesh, if we pass the following, right? If we say we want the X to be at a -2, the Y to be at 1, and the depth to be -5, we're going to change the position of the mesh, but then it's also going to be repeated for every single one. This is where we're going to use props and destructuring so that we could change the position for each independent spinning mesh. So for our first spinning mesh, we'll give the following a position of 0, 1, 0. And I'm just going to copy and paste the same position for all and then just change them. For the second one, we'll give it a -2, a 1, and a -5. And for our last spinning mesh, we're going to give it a 5, a 1, and a -2. Now we need some way to use this position, and we don't want to use the same position. So I'll get rid of it at this spinning mesh. Using destructuring, we'll go ahead and bring in position. And for our mesh here, position will then just take in our destructured position from our props here. Go ahead and save that. And then now you can see we have our main spinning mesh and then the 2 in the background on the left and the right. I want to change additional things. So I want to change the color. I want to change the, what do you call it? The arguments of our first one so that they are larger than the second. And we can just go ahead and do that. In our first spinning mesh, we'll pass in args and we will make this a 3, a 2, and a 1. So it's going to be wider than it is high, and the depth is going to remain 1. So refreshing, didn't seem to do anything. We seem to have broken something. Okay, so in our args, we pass the ambient light instead of passing it in our spinning mesh. So go ahead and add that there, but we'll need to take in this arguments right here. we can go ahead and add a comma. And then for our box buffer geometry, we'll just pass args as args. And now we would need to define the argument for our other two spinning mesh, but since they are going to have the default height, width, and the depth, we can just leave it as is and it will automatically set the height, depth, and width to ones. So we don't need to worry about that, but you can see we've kind of got our shapes going here for us, which is neat. What we want to do next is just make these stand out a little bit, and that's just by changing the color. We're going to give the bottom two, or the two in the back, a color of pink. And for our main mesh, we're going to give it a color of light blue. Go ahead and bring in color here. We can also apply color to the mesh standard material, and depending on whatever we pass, such as pink or light blue, it will then take in this. So we've got pink in the background, blue in the front. Let's go ahead and add some lighting just so that we can kind of have some sort of reflections, and then we'll add shadows. To add lighting right now, what I'm going to first do is just add some point lights on the left and the right, just so that they can be reflective a little bit. And then we'll add our main directional light, which will be our primary light source. To add a point light, we can just add point light like so. And I don't want it to have two tags. I just want it to be self-closing. So we'll have point light like that. And now with point light, we'll pass in the position and the intensity. So for our first position, we're going to give it the following positions. Again, it would be X, Y, and Z. So the X is going to be a -10, a 0, and a -20. And then for our intensity, we're going to give it a 0.5. And save that. If we preview, you can start seeing that there's a bit of a light source here coming in from the left side. Since our x-axis is having a -10, it's going to be pushed to the left side here. We want to add another point light, and we'll just copy and paste this again. We'll switch the intensity of this one to 1.5. Now the position for our second point light is going to have an x of 0, and it's going to have a y of -10, and then the depth is going to be 0. So actually this one looks like it's just going down here. So it's not necessarily to the right too much, but our light source is coming from the bottom. So you can see it hitting bottom right there. So our second point light, or light, what is it called? Point light, yeah. Our second point light's here at the bottom, and then our first one's here to the left. And then we're going to have a directional light coming down and casting a shadow. We'll add the mesh wobble at the end because that's the coolest part. Let's go back here and let's sort of separate this a little. So we have right here, actually JSX comments look really ugly. We're not adding that, who cares? Let's add the directional light, which is our main source of light. Think of it as a sun, and this directional light will cast shadows like I mentioned before. So let's go ahead and do that. Let's add directional light, and in the directional light, we're going to adjust the position. The position is going to be the following. So it's going to be similar to what we had for our bottom point light. It's going to be 10 pixels, not pixels, but 10 to the top. I wonder what the measurements are. I never really looked. I wonder if they are pixels or rems or whatever you measure, whatever Three.js uses to measure. But the intensity here is going to be set to 1.5. And then the size of our shadow map size width is going to be set to the following. So we can do shadow map size dash width. This will be set to 1024, and we also need the height. So don't forget to add an additional dash for the width and the height, and it's going to be lowercase. Width, that's funny, height, 1040. Finally, we need to adjust the cameras for the shadow, so the shadow camera. What we could do here is write shadow dash camera dash far, and this will be set to 50. And then I'm going to copy and paste this a few more times, because then we're going to edit the left, right, top, and bottom. So then shadow camera left is going to be set to a -10. And then we're adding an additional one and changing the right to +10. And then the shadow camera top, set that to 10. And then finally, the shadow camera bottom will be set to -10. Now, for some reason, it wrote shadow map up here, but it's going to say shadow map size dash width and dash height. I don't know where this shadow map came from, so go ahead and delete that. Let's save this and take a look at our project. So we've got that main source of light coming in at the very top, and it's illuminating our objects really, really nicely. feel like it might be a little too bright actually. So let's lower the intensity down a bit. Let's go back in our project. And if we want, we can lower the intensity to a 1. And then this would make it not as bright. Actually, for now, we'll leave it as 1.5 and then adjust as we continue. So what I want to do next is cast a shadow at the bottom. Like I mentioned at the very beginning, we cannot cast a shadow if we don't have a floor or a plane. So let's build that plane really quickly. And to do that, we're going to make some room for us. So underneath the point lights, we could create a new group. And then again, to create any sort of shape, we need to create a mesh first. And inside of this mesh, what we're going to do is use a plane geometry buffer or plane buffer geometry. And we're going to attach a geometry to it. And now for its arguments, it's going to take 2 arguments. And both of these arguments are going to be set to 100 and 100. And then we're also going to provide it a material. Now to create a shadow or to make this plane or a floor cast a shadow, or its main source is going to be a shadow, we will use a shadow material. But I want to see how this plane buffer geometry looks like on where it's going to be for our floor. And for that, I'll just go ahead and use a mesh standard material. And so I will go ahead and add mesh standard material, and we'll set the color of it to be, I don't know, yellow. But we'll make a comment saying this will need to cast a shadow. And for it to cast a shadow will, like I mentioned, require us to use something called shadow material. Now let's see how this plane buffer geometry looks like. So you can see that it's covering the entire screen, but what we want for it to do is sort of rotate and change its position to where it's going to be aligned perfectly to the floor, just so that these different objects, these cubes that we created, would be on top of it. So it's going to be this sort of laid out carpet or floor. To do that, we'll need to change the mesh's rotation. What we could do here is add a rotation, and for our x, we'll want to use a minus math.pi divided by 2. And then for our y and depth, we're setting that to 0. We also want to change the position, and for the position that it's going to carry is the following. It's a 0, a -3, and a 0. And if we save this and look at our preview, you will notice that the plane is sort of representing a floor now. It is completely rotated, and it's a plane, it's a floor. What more can I say? So that's awesome. Now we're going to make this cast our shadow, and we'll change that to the shadow material, and it's going to take in the shadow from our directional light that it's up here. It's going to be pointing down. So let's do that. Changing this mesh standard yellow, we're going to completely erase that and this comment. So we'll go ahead and add a shadow material here, and we're going to attach a material like so. Perfect. If we take a look at what's happening, nothing's going to be shown just because we haven't added the following attributes to work with shadows just yet. To work with shadows, what we're going to do is in our canvas, we're going to pass in shadow map. And then for our mesh, we want this mesh to cast a shadow. So this is going to have a cast shadow prop, as well as our directional light. This is where our main source of light is coming from. It's also going to cast our shadow. And then finally, this plane over here is going to receive the shadow. So we're casting shadows from our mesh and our light, and then this plane is receiving our shadow. So go ahead and add a receive shadow attribute in our floor or plane. Now if we take a look, you can see that it's showing our shadows now. However, they are extremely harsh. Changing the opacity of the shadow material should fix that just a bit for us. So adding an opacity of 0.3, it makes this just a bit lighter. No shadows, 100% black. So just don't leave it as an opacity of 1. Set it to whatever you like. Now I do want to include soft shadows. And you'll see the difference it really makes here. And soft shadows is going to be coming in from dry. To bring that in, let's go ahead and import soft shadows. And we're importing this from, like I mentioned before, this fancy little helper that we could use with our React 3 fiber. To execute soft shadows, just go ahead and execute at the very top. and it will soften up our shadows. Look how soft those look. Let's comment this out and preview. You can see that they are harsh and they are really defined. However, using that soft shadow function will then kind of soften them up for us. Okay, so we're getting there. We're almost done. We have the mesh wobble, which we need to add, as well as using React Spring to scale up and down these cubes. So let's go ahead and see if we could bring in the mesh wobble. To bring that in, actually, it's going to be coming in from dry as well. So we'll do mesh wobble material, and this is going to be really easy to add. So we have mesh standard material here. We'll just replace this with a mesh wobble material, and then we'll pass in additional props for it. The props we're passing in are the following. So we have speed, and speed is going to be determined by each specific one. They're going to change, but for now we'll add a speed of 1. And then for our factor, we're going to go ahead and set the factor to 0.6. Let's go ahead and take a look now. So now you can see that they are a bit wobbly, and depending on the speed and the factor, they do change in terms of how wobbly they get. So a speed of 3, it would start, moving. Look at that. It's really going now. And then the factor, if we change this to a factor of 2, it's going to get really intense. So now it's just super emphasized, and it kind of breaks for our middle one because it's too emphasized, and so it kind of just doesn't look good at all. So I will change this back to 0.6 and 1. Actually, it wasn't 1, was it? It was 1. Okay, 0.6 and 1, but then they are going to change dependent on the item. So we're going to bring in speed here, and then we're going to pass 1 with speed. Speed is going to be a prop that we're going to pass for each one. So we'll add a speed, and depending on what speed we want to add, it's going to vary. So I'm thinking that the speed of the 2 meshes in the back are going to be set to 6, and then the speed for our main light blue mesh is going to be set to 2. So let's save this. And so the 2 meshes in the back, the smaller ones, are much faster than the main one in the front. And I think that's better. I think if it's larger, it's supposed to move a bit slower because there's a lot more room to cover. But yeah, I think that looks good right there for our mesh wobble. We can also bring in an orbital control, and orbital control is going to be a snippet from dry as well. So bringing in orbit controls. I said orbital control, but it's just orbit control. We can pass orbit control at the very, very bottom here. So we'll just pass in orbit control, and then using orbit control, all we need to do is just pass it there, and we can start moving our canvas around like so. We can even zoom in and zoom out with our mouse, which is really, really neat. All right, so we're almost there. Let's just go ahead and use React Spring to add some animations to these, including just scaling them. So let's go back in our project. And I actually want to add this spinning mesh inside of the group that we created just for organization's sake. It's not going to change anything, but when we're building larger projects, we kind of want a better style to grouping. All right, we can go ahead and scroll to the very top, and then we'll import the following. So we're going to import useSpring, and we're also going to import A, which A represents animated, but you could use A for short. And we're importing this from React Spring. Now, be sure to add a /3 when you're working with Three.js or animating the mesh or the groups. And if you're working with HTML, it would only just be React Spring and not React Spring 3. So to get this going, what I'm going to do is we'll first want to create a state. So I'll add useState here at the very top. And then in our spinning mesh, we'll define the state. So I'll do const expand set expand, and we'll say useState and set this to false because initially they aren't expanded. Now with useSpring, we'll create the following. Typically they're called props because when you're just defining an animation without any functionality, it would just pass props. So if we define props, we'll pass props as style props, which is basic useSpring. In the documentation, that's just the basics of it, but we'll just say props here, useSpring. And then within this useSpring, we can assign different properties. Now, you need to make sure that, working with mesh, you could only work with the properties that mesh provide. You can't change the opacity. Opacity comes from the material, and other things. The main things that, you could change here are like, the position or the scale. And that's what we're going to actually do. We're changing the scale. So this scale is going to be dependent on if expand is true or not. And if expand is true, we'll set the height to 1.4. We'll set the width to 1.4 as well as its depth to 1.4. Otherwise, we're setting everything to what it is by default, which is 1. Now, with the mesh here, what we'll do is have an onClick event handler, and we'll just say onClick. We're going to just set expanded to the opposite of what expanded already is, which is false. And we could set it like, wow, what is that? We could set it like so. And I actually don't have expanded state, it's just called expand. Now to get this to scale, what we're adding is an additional scale property here. And then we're going to target props.scale, like so. So if we refresh, we can see that we've clearly broken the application for some reason. Now, the reason why it's not working is because if you think back to our Framer motion tutorials, we need to turn this into an animated component. To do that, we'll just add a dot. If we had imported animated at the top, it would be animated dot, and so on. With Framer, it's Framer. With Framer motion, it's motion dot, div or whatever that component is. So adding a dot will then turn this to an animated component, allowing us to use the useSpring hook or any Spring hook we want. So let's save this now and preview. And if we click, you can see that then expands our cube as well as the shadow. If we click on this pink box, it does the same. And so now we just have state that is assigned to each individual mesh. And when we click on each one, it will determine if it's expanding or not. Okay, I think that's going to do it for episode 1 of using React 3 Fiber. I think, we went through everything. We talked about lighting, shadows, creating mesh, everything that we need to sort of cover in order to create a basic yet, pretty looking application. Not really an application, but, Three.js, 3D app. That's going to do it for me. We are going to get way more advanced, but we've got to understand basic fundamentals. And this is the point of this. This is just episode 1. If you did enjoy, don't forget to leave a like. Don't forget to subscribe. Thank you so much, Cuba, Jaros, or Haros. I don't really know how to say your name. Cuba, thanks, man. I really appreciate that. Anyway, have a wonderful day, guys. I'll see you in the next episode. Take care of yourselves out there.